Today's video, we are on Lesson 3 of Unit 12, adding probabilities in two-way frequency tables. We'll be covering pages 406 to 409. Be helpful if you had a highlighter and a calculator just for adding and subtracting purposes. So sometimes we want to determine the probability that either event A happened or event B. We're going to take another look at Venn diagrams. Our first exercise: consider the spinner shown below that's been divided into 8 equally sized sectors of a circle. The spinner is spun once. In this experiment, we will let A be the event of it landing on an even, and B be the event of it landing on a prime number. Prime numbers. 1 is not prime. Our prime numbers start with 2, 3, 5, 7, not 9, 11, 13, right, and so on. Fill in the Venn diagram below with the actual numbers from the spinner. So we want evens for set A, prime for set B. Well, our first even 2 is also prime, so that would go in this overlap section, because it's contained in both set A and set B. 4, 6, and 8. Finish out set A. Primes, we have our 2, and then 3, 5, and 7. So that leaves us with 1 is neither even nor prime, so that goes on the outside. When we have 2 or more sets, we talk about their union and their intersection. The union and intersection of 2 sets. For 2 sets, A and B, their union, or which has this symbol, this is for union, and their intersection, and is this symbol, are given by A or B, also known as A union B, is a set of all x such that x is in A or x is in B. So it's the 2 sets joined. This is or union intersection. A and B is equal to A intersect B is a set of all x such that x is in A and x is in B. So this is and, or intersection. It's shared by both sets. It's the elements that are shared by both. From exercise number 1, write out the following 2 sets. A or B, otherwise known as A union B. A union B would equal 2, 3, 4, 5, 6, 7, and 8. A and B is what they have in common. Just this piece, which is 2. From exercise number 2, why is the equation the number of elements in set A or B equal to the number of elements in A plus the number of elements in B generally not true? Well, let's see, the number of elements in set A or B, that's 7, right? 2, 4, 6, 7. Does that equal the number in set A, 4, and the number in set plus the number in set B, 4 plus 4? No, that's not correct. Why is it? Because this 2 was counted twice. Right? Or the overlap, because the overlap was counted twice. The overlap was counted twice. The formula for the union of two sets, it would be the number of elements in A or B is equal to the number of elements in set A plus the number of elements in set B minus that overlap. The number of elements in set A and B. Again, OR is union, symbol is that, and is intersection, which is symbol is that. These are lowercase n's for number of. On the next page, we have a shading representation of and, or, and complement. Concerning all the people in the world, let A be the set of American citizens of the United States, and let B be the set of people who have brothers. The set of people who are Americans and have brothers is shown by the shaded region. So this is A and B. The set is written A intersect B, also can be read as A and B. The capital P is for probability of A and B. The set of people who are Americans or have brothers is represented by the shaded region in the Venn diagram below. This is the OR, A union B. And next, this set of people who are not Americans is represented by the shaded region in the Venn diagram, known as the complement of A. So this is everyone not in A. So not A, we say A with a raised C, superscript C, for A complement. I would also use the tilde A for not A. The set is written A and read A complement. And the probability that a randomly selected person is not American is written the probability of A complement. Again, the important thing here is the overlap, the and, that's intersection of, and the new symbol. And or is union of, and the symbol. Next, think about cars available at a dealership. Suppose a car is selected at random from the cars at a dealership. Let the event that the car has a manual transmission be denoted M. Let the event the car is a sedan be denoted by S. Venn diagram below shows the probabilities. Oftentimes when I'm given a Venn diagram with some probabilities noted on them, I will just go ahead and, okay, this is the and, right, the overlap, or intersection, and all three of these together, if I was to add them up, this is the or union of. Complete this sentence using and or. Probability of M This is and. Probability of M and S is the probability that a randomly selected car has a manual transmission and is a sedan. What is the value of the probability of M and S? That's our intersection. That's equal to 0.12. Complete this sentence using and or. The probability of M union S is the probability that a randomly selected car has a manual transmission or is a sedan. What is the value of the probability of M or S, or M union S? There's two ways of getting this, right? We know outside here is 0.19, so we could say, oh, it would have to equal 1 minus 0.19, which is 0.81. Or probability of M union S. We could take and add up all three of these. Is 0.09 plus 0.12 plus 0.60, which is 0.81. What is the value of the probability of S complement? We want everything outside of S. So everything outside of here would be the 0.01 plus the 0.19. .28. Which can also be gotten by probability of S complement would equal 1 minus the probability of S, which would be 1 minus 0.12 plus 0.60 is 0.72, which again is the 0.28. Explain the meaning of the probability of S complement. The probability that a randomly selected car is not a sedan. Now some work with the two-way frequency tables. Give us a good example of how events or sets can combine, their union, and overlap, their intersection. Right? Combine is union, overlap is the intersection. Union is or, overlap or intersection is and. Exercise 6, a small high school surveyed 52 of its seniors about their plans after they graduate. They found the following data and wanted to analyze it based on gender. In this case, if we pick a student at random, we can place them into one of 4 categories, or 4 events. M is male, let's note that. F is for female. C is for going to college. And N is for not going to college. So we have 29 total going to college, 23 not going, total 52. And it's broken up between male, 30 males, 22 females. A, give the values of each of the following. The number of males. Number of males is the total, 30. Number of females, 22. Number of males and going to college. M and C is this 16. Number of female and going to college. Female and going to college, 13. Oh, I skipped these over here. I'll do them now. Number of going to college, total 29, and number not going to college 23. Number of female or going to college. Female 22 or going to college 29 and 22, but that's meaning that 13 would have been counted twice. So rather, let me just take the 22 plus the 16 others. $38. Again, it can be gotten also by taking the female plus the going to college, 29, subtracting that 13. So actually, let's do that. Number of female or college would be number of female plus number of college minus female and college. Sorry about that. Try this over here. And this number of female and college. This was saying the same. Female 22 plus 29, 51 minus 13 is the 38. What is the probability that a person picked at random would be a female who is going to college? So now this is probability. So we want probability of female and going to college. I'll represent this using either a union or an intersection. So this is intersection. Probability of female and college. Female and college is the 13 out of the total 52. What is the probability that a person picked at random would be a female or someone going to college? Represent this using union or intersection. This is union or. So the probability of female or, that's the U, female or college would equal, that's our 38 over 52. Explain why the probability of female or college does not equal the probability of female plus the probability of college. 38 over 52 does not equal probability of females 22 over 52 and probability of college is 29 over 52. Again, the overlap of the 13 female is counted twice. If we were to use that, the overlap of 13 female would be counted twice. So in general, the probability of A or B would equal the probability of A plus the probability of B minus the overlap that would have been counted twice, the probability of A and B. You are going to memorize that. That's one of our first formulas. Probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So sometimes we can avoid the probability law when we encounter simple problems. where we can simply keep track of the elements of the sample space. Exercise 7, a standard 6-sided die is rolled twice. Find the probability that the number rolled was either an even or a multiple of 3. Represent this problem and the sets involved using a Venn diagram, even though you don't need it. Verify the probability addition rule from exercise number 6E. So even and a multiple of 3. Say E for even, multiple of 3, I'm going to say M3. 1 is neither, 2 is even, 3 is a multiple of 3, 4 is even, 5 is neither, 6 is even and a multiple of 3. Probability of even or multiple of 3 would equal the probability of even plus the probability of multiple of 3 minus the probability of even and multiple of 3. Even would be 3 out of 6. Multiple of 3, 2 out of 6. And even and multiple of 3, 1. So 5, 1 out of 6. 5 minus 1 is 4, or 2/3. And lastly, insurance companies typically try to sell many different policies to the same customers. At one such company, 56% of all customers have car insurance, 48% have homeowners insurance, 18 have both. A customer is picked at random. Find the probability that he or she has at least one of the policies. So that means probability of car or home is going to equal the probability of car plus the probability of home minus the probability of car and home. Car insurance, 56%. Homeowner, 0.48 minus both, 0.18 equal to 0.86. Find the probability she or he has neither of the policies. Well, that would be everything outside, so that would be 1 minus the probability of C or H. It's the complement. They have car or home. Here we're looking for neither. So that's the complement. 1 minus 0.86, which is 0.14. Thank you for your attention today.